So we're going to talk today about the other type of electrochemical cell called an electrolytic cell. Sometimes this is also called electrolysis, specifically when we're working with water. And the other way that we talk about electrolytic cells is when we talk about the process of electroplating. So all of these terms basically involve an electrolytic cell, okay? So we're going to talk a little bit about these. We know from our discussion of a voltaic cell, electrons want to flow from a high reactive metal to a low reactive metal Again, we use table J to see which one is high, which one is low. And they want to do so spontaneously. And we use the analogy that water tends to run downhill naturally on its own. You don't have to pump it. It just runs downhill spontaneously because of a force called gravity. We've also talked about how your room spontaneously, in my room, spontaneously becomes messy, and it seems like you do nothing and you look at it and it's a mess. So you have to put energy in to clean it. So in this example, electrons will readily flow from zinc to a copper ion, and they will do so spontaneously. And we'll just say actually to copper. They'll flow from zinc to copper, and they'll do so spontaneously. So, can electrons flow the other way, from low to high reactivity? Any thoughts?
Yes.
I agree with you, Zoe, they can, but what do you have to do? You've got to provide a constant input of what, Cassie? If you want electrons to flow from low to high, you need to put in a constant input of energy. So the answer is yes, but a constant input of energy is needed. You need a constant input of energy. You taking notes back there? Opie? Are you taking notes? Copta, are you taking notes? Cassie, Copta, are you taking notes? Caslin Lynette Copta, are you taking notes, and do you need a pencil and pen and paper?
I need a piece of paper.
Come get one. This is challenging stuff. I'll give you a couple.
Yeah. How much would this be worth? Like half a cent.
Yeah, I mean, just a little bit's not worth a lot, but okay. So what we need to do here is we generally are going to provide that continuous input of electrical energy by using a battery. So a battery you can think of as serving as an electron pump.
I can't spell.
And what that means is it's going to force electrons to go from low to high. So when you have a battery, it will force electrons to go in this pathway from low to high reactivities in terms of metals. So you can actually make electrons leave copper and go back to zinc if you supply a battery to do so. This is what happens in an electrolytic cell. In an electrolytic cell, we still have an anode and we still have a cathode. But one of the differences is the value of the sign that is placed on them. We call the anode now positive, whereas in a voltaic cell it was negative. The cathode we call negative. You still have anox and red cap applying, which means where does oxidation occur? At the anode. Where does reduction occur? At the cathode. Very good. And we can force electrons now to go from the anode to the cathode, and the anode is going to be a low reactive metal on table J to a high reactive metal on table J. But what do we have to do that? We have to use electrical energy, and we do that with a battery. Very good. So we can make electrons do this, but we have to have a battery in order to do so. Okay, now one of the ways that we essentially do this is when you basically make electricity flow through water. We know that's a little bit of a misleading statement because electrons themselves can't flow through solution. Only ions can. But if we take a solution and in this solution we put test tubes that look like this. Stand them upright. We fill those test tubes to the top with water. I'm just going to leave a little bit of air at the top to show here that basically those are submerged, they're filled with water. Then if we take a battery and we run, oops, missed my,
No, you can't. No.
little bird. We run our wire. All right, sorry.
Looks like an elephant.
It does. We run our wire into each electrode. All right, so maybe I will just start over.
At least let me look at
I'm the least OCD person, and I just can't deal with it. So,
This might go. Let's watch
all right.
That's a good question.
I just don't want to put them all the way to the bottom, okay?
So does it matter which way your positive is and which way your negative is?
No,
You almost.
but it does matter what gas is going to be produced. I did too. Now, I said to you that this is a solution. And why did I not just say it's liquid water? Because if it's pure liquid water, electrolysis, which is what we're talking about, will not work. Okay? It has to be a solution that has ions. So I'm going to use in this pure water, I'm going to add some sodium sulfate. That will produce sodium ions and sulfate ions. Okay, so we've got a lot of sodium and sulfate that are floating around in this solution. And it is important, in fact, it's critical that ions are present. Why do you think ions must be present? Electricity cannot flow through water. Only ions carry charge through solution. So ions must be present to carry charge through solution. That's why we call them electrolytes.
So what kind of water wouldn't? Because if you have like water from like a lake or something.
Yeah,
Well,
that would have ions.
what kind of water doesn't?
Distilled water. Yep. Only distilled water essentially doesn't have ions. Okay, so at this point, we have a battery. We have a basically solution of H2O liquid and sodium sulfate, and we put two electric probes into test tubes that are filled with water. Now what's going to happen, at each one of the tips of those wires, you're going to start to generate gas. And that gas is going to rise to the top of the test tube, and it's actually going to force the water out of each of those test tubes, and if you let it run long enough, you'll fill up the test tubes with pure gas. One on the left, one on the right, and the question is, well, what is the gas that's being filled up? Well, the first thing that happens here is that we have an anode